Mungu ibariki Tanzania, dumisha uhuru na umoja wake kwa waume na watoto. Mungu ibariki Tanzania na watu wake. Ibariki Tanzania, ibariki Tanzania, tubariki watoto wa Tanzania.
How are you, everybody who is watching this fantastic video? I'd like to take this opportunity to welcome all the local, national, and international students into our fantastic online school and fantastic program of learning, enjoying advanced chemistry. My name is Olenjolai, simply Olenjolai. I thank God by His own grace that who has given me a gift of teaching, so I'll be teaching you the beauty of advanced chemistry. And then I'll be focusing on the syllabus of the Republic of Tanzania, and this is the national flag. I will take this opportunity to welcome all the international students to enjoy the beauty of advanced chemistry under the syllabus of the Republic of Tanzania. So, before we go into too much details on what I've prepared, I would like just to give you the overview. So, in our online school, we have different departments. We have departments of advanced chemistry, departments of advanced mathematics, departments of advanced physics. And then in these departments, we are teaching also subjects, but mainly we are focusing on advanced secondary students, Form 5 and Form 6, that's what we call in Tanzania. In some other countries, they might be just calling that maybe class 13, class 14, or advanced level in general. So educational system from country to country is quite different. But remember that the contents that we'll be teaching you are cross-cutting contents, and this is all about what you have to cover as a high school, secondary students in advanced chemistry. Again, I'd like to take this opportunity to welcome. The name of our online school is called TANZANIA Online Advanced Secondary School, in square bracket OLENJOLAIM. And our official YouTube channel that you can access our contents is called TANZANIA Online A-Level Secondary School, in square bracket OLENJOLAIM. We are in departments of advanced chemistry. The subject today is called advanced chemistry. And this is main topic 3, that's called advanced organic chemistry. And we would like to dedicate this content to pre-Form 5 students, Form 5 students, Form 6 students, pre-Form 6 students, reciters, QT, grade 12 teachers, and chemists. This is chapter 2, that titled as saturated. So it's titled as saturated and the unsaturated, saturated and the unsaturated hydrocarbons. Saturated and unsaturated hydrocarbons. This is session 21. We are still proceeding with chemical reactions of alkenes. So the session, just to do the quick review session 20. So session 20 is titled as Chemical Reactions of Alkenes. So there where we began our journey. And the first sentence that we made that alkenes are reactive organic compounds compared to alkane. And then we mentioned the property which makes them to be reactive is localized pi bond. Localized pi bond electron. Okay? And then we say that this one undergo electrophilic addition reaction. That's the first type of chemical reaction that we began of alkene. And then we say that this is governed by what? By Markovnikov's rule. That's what we started. And then we began, and the first reactions is what? Dehydrogenation or the halogenation. How do we call the first reaction? The first reactions are reactions with hydrogen halides.
Yes.
So reaction between alkene, which is CnH2n, resulting with hydrogen halides. Then we taught you the chemical reaction between alkenes with bromine water, which means water under presence of water or bromine. Or reactions between alkenes and bromine and presence of water. Then finally we taught you about reaction between alkenes with concentrated sulfuric acid. Then we left the homework for you. And the homework that we left for you, we left you so many homeworks, but the first, I think that is one of the homework that we left you, which is very interesting, that we like to do the correction at this time, how to explain briefly the methods that can be used to distinguish alkenes from what? From other organic compounds. From other organic compounds. So there are two methods that we can teach you, or which we taught you, but we didn't just give you the details that these two methods can be used to separate alkenes from other organic compounds. The first method, so this now it's a correction of homework 20, but this is one of the questions. So the reaction between alkenes and the bromine water is used to test and distinguish alkenes from other organic compounds. So the first method, the reaction between alkenes and bromine water, is used to test and distinguish alkenes from other organic compounds. So alkenes the color of bromine water is brown. So you say the alkenes, the color, colorize the bromine water to form bromoalkanol. So this is the first method. So I taught you how bromine water reacts with alkene to form bromoalkanol. So the bromoalkanol it's colorless. It is colorless organic compound. But the first method. The second method, of distinguishing alkene from the mix of other organic compounds, say that the second method we say alkenes react with concentrated sulfuric acid to form white precipitate. So while other organic compounds they don't form white precipitate of alkaline hydrogen sulfate. Alkaline hydrogen sulfate. So alkenes react with concentrated sulfuric acid to form white precipitate of alkaline hydrogen sulfate. So that's the second method. So it means that the other organic compounds, for example, alcohol, alkyl halide, benzene, or toluene, or carbonate compounds, they don't, when they react with these other compounds, when they react with bromine water or concentrated sulfuric acid, they don't form the same product as what alkene form when they react with this. All right? Are we together? Okay. And keep it at the house. Okay, so sometimes you can be asked that maybe separate the following also, maybe extracting alkene from the mix of the organic compounds. So there's a different style that the questions might be asked. So let us continue with electrophilic with examples of electrophilic. Examples of electrophilic addition. Examples of electrophilic addition of alkenes. Examples of electrophilic additions of alkenes. So I still have two examples. So I told you the first one, we say that hydration of reactions with water. So hydration of alkenes for reaction between alkenes and water. So in previous session I told you the meaning of hydration. So I say that alkenes reacting with water under the presence of sulfuric acid. So you say that the alkanes react with water under the presence of sulfuric acid. Form what? To form alcohol. Form alcohol. So general with chemical question, it is, so you have alkenes plus water is form alcohol. But in the presence of water, sulfuric acid. So the functional group of alkene plus water under the presence of sulfuric acid so the product for this reaction alcohol group will be attached to here and hydrogens will be attached there. Okay, so for those who are writing number of example, tell me this the example 10, if I'm not mistaken. Okay, so complete the following chemical reaction, organic reaction with mechanism. CH2 plus water. Then, and the presence of sulfuric acid. Then we have CH3, CH3 plus water and the presence of sulfuric acid. Then we have phenol. This is sulfuric acid. Okay, so we have those three questions. I'll be just doing one or two. I'll do just two in order to give you a brief overview. So solution. The first chemical reaction, we have the functional group of alkene reacting with water or undergo hydrolysis reaction under the hydration reaction, which hydration means that we are adding water. The hydration is just you are removing water from organic compound. So dehydration, you are removing water. Hydration, you are adding water into organic compound. That's what you have to know. So the mechanism for this reaction, just write the open structure of your organic compound. Here you have double bonds. Here you have a bond between carbon and hydrogen, a single bond, plus water. But water, remember, it's a nucleophile. And also you have sulfuric acid. If you do remember, I told you that how you can write open structure of sulfuric acid. So here we have double bond with oxygen, double with oxygen, a single bond with oxygen and hydrogen. Then we have single bond like this. So sulfur forms 6 bonds in formations of sulfuric acid. So remember that alkenes, this is one of the examples of electrophilic additional reaction. So first of all, before you break the bonds, you have to know, or you have to make sure that you have electrophile in your reactant. So water is not electrophile, water is a nucleophile. So to have electrophile, it means that we have to, it means that in this reaction, first of all, the bond between oxygen and hydrogen sulfuric acid will break down to have electrophile. And oxygen will be destroying all the bonding electrons. So you have to listen carefully. It's a little bit different. It's not like example 3. So then here we have our open structure. So here we have bonds with carbons, we have a single bond with hydrogen, we have a single bond like this. Then plus what? Plus water as nucleophile. Then plus what? Plus oxygen. So with bond with hydrogen. And then we have sulfur, we have double bond with oxygen, double bond with oxygen. Then oxygen, this is partially negative. Plus what? Hydrogen, partially positive. Okay. So if that's the case, we remember the Markovnikov's rules. When the incoming electrophile is added into organic compounds, the incoming electrophile will be added into mostly hydrogenated carbon. So we have this compound, we have here hydrogen, we have here carbon, we have a single bond, this is partially positive, and then here we have carbon, bond between carbon and hydrogen, So this is partially negative. No, we have our electrophile which is added already. So then plus what? Plus water as nucleophile. Then plus what? Hydrogen sulfate. So oxygen, sulfur dioxide 3. But this is negative. So because we want to add, the reactions are iterations, addition of water. So now our organic compound, this is a carbonium ion, so it's lacking water molecule. So it means that this nucleophile will be added into this carbon. So you have an alkyl group like this. Here we have a bond between carbon and hydrogen. So then we have what? We have water, like this. And then we have a single bond, which is just 3. So water is saturated, so the bond between oxygen and hydrogen will break down. So you have hydrogen, so on this side we have oxygen, then sulfur dioxide, but as a negative molecule. So on this side, we have this alkyl compound. We have a bond here. This is bond with hydrogen. And here we have OH. Here we have double, we have CH3. So plus what? Plus hydrogen, partially positive, plus oxygen, partially negative, sulfur trioxide. So in this case, we have formed the alcohol compound. Then plus what? So hydrogen and this one. So the nucleophile donates electrons to electrophile. Then we form what? Sulfuric acid. So the overall reaction of alkene with water is this. CH2 plus what? Plus water. presence of what? Of sulfuric acid. So the product is what? CH hydroxide and CH3. So now remember that this is the phenyl. So phenyl. And here, so means that phenyl reacts with water. So Roman 1, Roman 2 is your homework. This is your homework to 1. And this one is your homework. Just to follow the same procedures as these procedures. So the only thing, the organic compound is the one that's going to change, but you have to be careful and identify where the double bond is, and you have to be careful where the nucleophile is going to be added and the electrophile. And you have to apply Marconi's rule. Okay, so I believe that you can do that. You can do example 10 Roman 2 and example 11 and example 10 Roman 3. That's why I did for the general alkenes organic compound. So the fifth and the last example for electrophilic additions of alkene is reaction with halogens. Chemical reaction between alkenes, chemical reaction between alkenes, and halogen. Chemical reaction between alkene and halogen. So alkenes react with halogen under the low temperature. At the low temperature from the low temperature in that condition, or infuse the light to form vicinal compound. Vicinal organic compounds. So overall, not general weight chemical equation alkenes react with halogen and form what? Vicinal compound. Addition is low temperature and also dark condition. So let me just write the general chemical question. General molecular chemical question. So the alkyl group the alkenes react with halogen and a low temperature in that condition. That condition, the compound is a decimal compound. Here we have X, and here we have X. So examples. For example, if you have a sin react with chlorine, low temperature in NAC. So the product is 1,2 dichloroethane. If you have this one, react with bromine under low temperature. In that condition, so the product is CH3, CH, bromine, CH, bromine, CH3. So you know how the reaction takes place. So then there's no need for you to bother yourself about mechanism, because it's just the bond between carbon and hydrogens break down. Two bonds between carbon and hydrogens are the one that break down to form the vicinal compound. So we say again, those are the 5 examples of electrophilic addition reaction. You can find more. So let me teach you now another subtitle, which is titled as other chemical reaction. Other chemical reaction. Other chemical reactions of what? Other chemical reaction of alkenes. Other chemical reactions of alkenes. So instead of electrophilic addition reaction, instead of electrophilic addition reaction, alkenes undergo other chemical reaction. Undergo other chemical reactions. Undergo other chemical reactions. Undergo other chemical reactions. So instead of electrophilic addition reaction, alkenes undergo other chemical reactions. So the following are some of the other chemical reactions of alkenes. The first one, so this will make reaction. Okay. So number one, back to the sixth chemical reaction for alkenes, it's called the polymerization. Say with me, polymerization. Polymerization is a topic in organic chemistry, but we usually teach Form 6 advanced secondary students about the build of it. Polymerization. Say with me, polymerization. So alkene undergo polymerization reaction to form polymer compounds. Form polymer compounds. Example, ethene undergo polymerization ethene undergo polymerization by adding itself from a large molecule of polymer compound, large molecule of polymer called the polyethylene. Ethene add itself form a large molecule that we call in organic chemistry polyethylene. So that is the first chemical reaction. So I don't want to go into too much details of polymerization because it's a topic. So first question, what are the means of polymerization? And we have to dig in it. And one of the examples of polymerization reaction is how ethene adds itself to form polyethylene. Here's some other examples of polymerized organic compounds, and it's called the nylon 6,6. Nylon 6,6. So this is the first It's not electrophilic addition reaction. Remember that. This is the other organic reaction of alkene. The other organic reactions that alkene can undergo, which is not electrophilic addition reaction, we call them oxidation. Oxidation. Oxidation reactions. So alkene can undergo various or can undergo oxidation reaction in different conditions. Alkenes can undergo oxidation chemical reaction in different conditions. So alkenes can undergo oxidation chemical reaction in different conditions. The first one is combustion. Combustion. Combustion chemical reaction. Combustion chemical reaction. Combustion chemical reaction. So alkenes undergo combustion reaction in the air. Can undergo combustion reaction when it reacts with oxygen gas and air to form carbon dioxide, and the water. So alkenes actually react with oxygen to form carbon dioxide plus water. So, if you take the functional group of alkene and allow combustion, regardless of number of carbons, the product is carbon dioxide gas plus water. Okay, so the second oxidation reaction is 2.2. It's chemical reaction between alkanes. So this is combustion chemical reaction, and this one is oxidation. So it's potassium permanganate. Potassium permanganate. Potassium permanganate. So these oxidations of potassium, of what the oxidation with potassium permanganate, alkene can undergo it in acidic medium and also in alkaline medium. So let us start that. In aqueous solution, in neutral aqueous media or in alkaline media. In alkaline media. Alkaline media. So alkene alkenes undergo oxidation, chemical reaction with potassium permanganate in alkaline medium form diols. The means of diols, two molecules of water or two functional group of alcohol. So diols is closely relating is water plus alcohol. From diols, single diol. So two molecules of water. So general molecular equation we say that we have alkene then it undergoes oxidation with potassium permanganate in alkaline medium. But this is called when it's alkaline medium in presence of sodium hydroxide. Form what? Form CH, CH2, hydroxide. So this means of what? So you have two molecules of what? Of hydroxide. So example, the syn undergo oxidation and according potassium permanganate in alkaline medium. This one will form CH2 hydroxide, and here we have hydroxide. complete. So that is oxidation reaction between potassium permanganate and alkene in acidic, in basic medium, so in alkaline medium. So in acidic medium depends whether it is branched or unbranched alkene. And these chemical reactions are very important because we need them in the next topic of what? In solving problems of conversion of the chemical reactions and distinguishing. So this is the alkaline medium. B in acidic medium. So in acidic medium, we have, so it depends whether it is branched alkenes or unbranched alkenes. For unbranched alkenes, also it depends whether they are unbranched alkene with terminal double bond or unbranched alkene. Listen carefully. We have two, it means that we have what? For alkenes, we have two. We have two forms of alkene. It can be unbranched alkene or it can be branched alkene. So unbranched alkene can be unbranched alkenes or it can be branched alkene. So with unbranched alkene, we can have unbranched alkene with terminal double bond or unbranched alkene with inner double bond. With branched alkenes, you have only branched alkenes. So you have to listen carefully. So in acidic medium, say that let us start with unbranched alkene. Special reactions of unbranched alkene with potassium permanganate. We are still in oxidation. Unbranched alkenes. So say that in alkenes, there are two types of unbranched alkenes, namely, the first one is called the unbranched alkene is terminal double bond. Second one is unbranched alkenes with inner double bond. So it's intent. That's why I say that I ask all my national and international students to pay high attention when dealing with this concept. Why? Because each alkene can form its product. So let us start with B, Roman 1. So say that unbranched unbranched alkenes with terminal double bond undergo oxidation, chemical reaction with potassium or manganate in acidic medium for red compounds, carboxylic acid, carboxylic acid, carbon dioxide, and what? And water. So when you say unbranched alkene, for example, so this is unbranched alkene, but with terminal double bonds. When you say terminal double bond, it means the double bond is either at the beginning of organic compound or at the end of the organic compound. So when it's undergo oxidation with potassium or manganate in acidic medium, so the acidic medium in most cases is shown by hydrogen. Sometimes some of the books you can see something like this one, concentrations, mean that you find 4 and then you have the symbol of concentration. You can have 4, you have a symbol of concentration, then oxidation. So this means oxidation. Okay? So when you say this symbol means oxidation, but even this one, but oxidation in acidic medium. So we say that when unbranched alkenes undergo oxidation, chemical reaction with potassium and manganate in acidic medium, it forms what? It forms carboxylic acid. So listen carefully, carboxylic acid, and this is the carboxylic acid that will be formed. So that will be that the carboxylic acid that will be formed means this bond will not. Last word. Form carboxylic acid plus carbon dioxide and plus what? Water. So if, for example, we have propene, and this one undergo oxidation is potassium, manganate, acidic medium, and here we are going to have SMRT plus what? Carbon dioxide plus what? Water. So this is, okay, so this is in gaseous state, this is can be in aqua state, this is base, this is liquid. So B, Roman 2, we say that unbranched alkene with inner bond, in inner double bond react with acidified potassium manganate to form 2 moles of carboxylic acid. Unbranched alkenes I'm about to finish this section. Unbranch the alkene with inner bond, inner double bond. So there with terminal double bond, okay, fine. With inner double bond, react with acidified potassium permanganate solution. React with acidified potassium permanganate solution to form what? To form two moles of carboxylic 2 moles of carboxylic acids. So it's formed 2 moles of carboxylic acid. So the general reactions to say that this is alkene with inner double bond. So this it can have maybe 1 carbon, while this one 3 carbons. This, so the number of carbons between R and R dash, it might be the same or may be different. So when they undergo reaction with potassium permanganate in acidic medium, then the product is 2 molecules of carboxylic acid, that's R dash COOH. So example, CCD plus this is an acidified potassium manganate in acidic medium. So this is example of inner double bond. Okay, so this is representing R and this is representing R dash. They might have the same number of carbons, or they might have different number of carbons. So the product here, this one, the bond will break. And when it will break, because it is oxidation, the remaining part will have again another bond. So we have double bond with oxygen and single bond. Then this part also will form CH3, carbon, single bond, double bond with what? Oxygen, single bond with what? With hydrogen. So this is the carboxylic acid and this is the carboxylic acid. So because it's the same, so you can say 2 ethanoic acid. So there's no mechanism in case of oxidation reaction, but you have to know how the reactions break or take place. For instance, for this case, you see, I told you, for this case, this is terminal double bond. The double bond might be at the end or at the beginning of organic compound. For example, for this, let's say for this compound. So you see that the bond breakdowns there. Then this part of with single carbon will form what? Carbon dioxide. While the remaining part will form what? Carboxylic acid. Listen carefully. Let me repeat. There's no, I haven't seen any mechanisms with oxidation reactions or reduction reaction of organic compound. The only thing which I always use to teach my students, they have to understand how the reaction takes place. That's all. You should not claim, but you have to understand. So for this reaction, I say stop writing. For these reactions, when I branch the alkenes undergo with terminal double bond, because the key point is terminal double bonds, undergo oxidation chemical reaction with potassium permanganate in acidic media, then you have to understand that this bond break down. Then the carbon with Means the organic compounds with the single carbon will form carbon dioxide, and the remaining part of organic compound will form carboxylic acid. That's why you have carboxylic acid plus what? Carbon dioxide, and plus water. You have to remember water. Why water? Because we have also some hydrogens of this carbon dioxide, of this carbon which has been converted into carbon dioxide. Are we together? But from here you can see really the reaction is oxidation. Why? Because oxidation, one of the definitions of oxidation reaction, addition of oxygen. So it means that for this case, so here in this organic compounds, because we have only one molecule of organic compounds, we have two atoms of oxygen atom, while in reactant side we had what? So it means oxidation, so you are adding oxygen. Sometimes you can remove hydrogen, or you can remove hydrogens. Sometimes you are not adding oxygen, so it depends which definitions you are using. But any definitions of oxidations verify the truth. For this one, for this unbranched alkene, when within a double bond, so the double bond breakdowns and form two molecules of what? Of organic compound. So you see there, means that the bonds means that the reaction part will be the pi bond electrons. So this molecule form carboxylic and this molecule form what? Carboxylic. So, for example, if you have another molecule like this one, CH2,
Sir,
yes,
there the bond are 5
the bond are 5.
in carbon.
Where? Where bonds are 5? Be careful, open your eyes. When reactors acidify potassium permanganate, for example, this one, so you have a double bond between this carbon and this carbon. So let me just write them because students now, they don't see. So they are saying that there's a 5 bond, others they can tell me there are 3 bonds, others they can tell me there are 7 bonds, because they don't concentrate. You have to concentrate. Okay, so here we have, this is organic or unbranched alkene. Okay. So we say that if that's the case, we say, okay, fine. So when this one undergo oxidation reaction, so this part will break down. So we form propanoic acid, CH3, CH2. This is propanoic acid plus what? Plus ethanoic acid. That's all. Simple. Are we together?
Yes.
Okay. So another oxidation reaction is the hydrogenation reaction, which I taught in Alkenes. So you have to refer session what? You have to refer session 14 and session 14, session 13 and 14. I talked about hydrogenations of what? Hydrogenation reaction. Session 11 and 12. Where I talked about hydrogenation reaction, which it used to prepare what? Prepare session 14, if I'm not mistaken. Between session 11 and session 14, I talked about the hydrogenation reaction. So, where alkene react with halogens under the presence of nickel catalyst and temperature of 200 to form what? Alkane. So, the homework, it's time for the homework. Let me end this session here because your mind is a little bit overloaded. So, this is homework 21. The question is, what is the product when branched? I told you about branched. When branched, alkenes react with acidified potassium permanganate. So you have to explain to me and then you give me an example. So explain and give 3 examples. So ladies and gentlemen, this is the end of session 21, which is chemical reactions. And today I told you about 2 examples of electrophilic additions of alkenes. And I told you about the other 3 in total, organic reactions between alkenes with other organic compounds, but it's not the electrophilic additional reaction. So make sure that you do all the homeworks, all the questions that I've left you for the homework. And you join me in the next session, which will be session 22, when I'll teach you about ozonolysis of alkenes. It's one of the reactions which is very important, oxidation by using the ozone oxygen. And then, because we have also branched and unbranched, so we'll be discussing about something else there. Then we may do some few questions, almost 3 to 4 conventional questions. So now we can answer some questions, some simple questions of conversion, of converting one organic compounds to form another organic compound. So stay tuned, keep enjoying the beauty of advanced organic chemistry, and keep enjoying the beauty of saturated and unsaturated hydrocarbons. Ask your questions in the comment section below. And in case you have anything or any challenge in organic chemistry, let me know in the comment section. And see you, keep informing some other students about the beauty of advanced organic chemistry. Remember to subscribe. And then remember also to offer your free Thanksgiving in order to support this program through online training with any amount of your free Thanksgiving. So until we meet in the next session, this is Olenjolai from Tanzania. See you in session